welcome to Math 120, Section 5.4. Today we're going to be talking about polynomial and rational inequalities. At the top of your handout, you're going to see that I've typed the steps we're going to be following. So at this point, you should pause the video, read through those steps, and then we'll continue in a moment. In example 1, we're going to solve each inequality. Now, it's tempting when you look at a problem like example A here to say this is so close to something we've seen before where we have the equation and we have that equal to 0 that you want to come in and use those same ideas. And you think, well, okay, I can use the zero factor property, set each one of these factors equal to 0 and see what that does for us. However, the problem with that is that by doing that, we're going to figure out where the interesting things are for the x-axis, but it doesn't really tell us which areas we want to include and which areas we don't want to include. So you'll notice in the directions that I've added using a sign chart, just to give you a hint that you really want to think about this as a sign chart kind of problem. So let's go ahead and check out part A and see what we can see. So you'll notice in part A, we have the expression on the left-hand side, and we have the 0 on the right-hand side, and the expression on the left-hand side is factored. Because of the setup, we're actually ready to go directly to the x-axis for our sign chart. Because it's already factored, we can read off the zeros. We know that -2 and +3 are going to be the two interesting x values here. And then, just like we did back in section 5.3 when we were graphing rational expressions, we can come in and think about different x values that live in each one of these regions, and that's going to give us a sense of what's happening with our function. So let's choose the region to the left of -2. An x value of -3 lives there. And you'll notice over here on the left, I have just rewritten the expression for the left-hand side, x plus 2 times x minus 3 quantity squared. And just like we did when we were looking at the graphs in 5.3, I really don't care about the numbers, I care about the signs when we plug in something like that -3. So if I plug in -3 here, it's going to be -3 plus 2. -3 plus 2 is going to be a negative answer. And then over here we have -3 minus 3, that's a negative, then square that, that's going to be a positive. So what we have then is a negative times a positive. A negative times a positive is going to be a negative. Now that we have that, we can go ahead and check out the next region. So something between -2 and 3, we would have an x value of 0 there. Again, let's see what's happening in terms of our signs. 0 plus 2, that's going to be positive. And then 0 minus 3, negative, but then square that, that's going to be positive as well. And we have then that this is going to be positive. And finally, something to the right of 3. So an x value of 4 would live over there. 4 plus 2 is going to be positive. 4 minus 3 is going to be positive, and square that. Again, it's going to be positive. So we're going to get a positive in that region. And once again, remember from section 5.3, we now know then that if we have this x value of -3 giving us a y value that is negative, every x value in that entire region is going to give us a negative value as well. So now that we have the regions and the signs, what we want to do is think back to the inequality and say less than 0. Well, another way of saying less than 0 is that we're interested in numbers that are negative. So we want to find the regions on this graph where our y values are negative. So this is a region where our y values are negative. This region, the y values are positive. I'm not interested in that then. And this is a region where my y values are positive as well. So the only region that I'm interested in is this one to the left of -2. So now I have to decide then, do I want to include that -2 itself? Well, if I plug in that -2 here, I'm going to get the number 0. And because this is a strict inequality, there's no equal to on that less than, I'm not interested in that endpoint of -2. So I'm going to go ahead and put a parenthesis there saying I'm not interested in that part. And then I would continue going to the right forever here. So let's go ahead and write down a nice inequality way of saying this. So we can write our answers in interval notation, or we can write down our answers in set builder notation. Your author tends to do interval notation in this section. So let's go ahead and do interval notation and describe this particular region in interval notation. So from left to right, we're going forever to the left. So we have negative infinity there. And then we continue to the right until we hit that negative 2. And we're not going to include that negative 2. So I'm going to put a parenthesis there. So there's our answer for part A. Parenthesis, negative infinity, comma, negative 2, parenthesis. Now, as you look at part B, we once again are looking at a problem that is a polynomial inequality. But this time, we don't have the 0 on one side or the other. So we're going to have to start by getting the 0. So let's add the 15x squared to both sides. We have 3x to the third plus 15x squared, and that's greater than or equal to 0. The other thing that makes B different than A is that we don't have the factored form. And because we don't have the factored form on the left-hand side, I can't immediately read off the interesting x values. So let's go ahead and do some factoring. As you look at the left-hand side, notice we have a 3 and a 15, we have an x to the third and an x squared, so we can pull out a greatest common factor. Looks like we can pull out a 3x squared. So if I pull a 3x squared out of 3x to the third, we're going to be left with an x. And if I pull a 3x squared out of a 15x squared, we're going to be left with a positive 5. This is greater than or equal to 0. So now, as I look at my factored form, I can see that 0 and negative 5 are going to be the two interesting x values. So let's go ahead and create a sign chart using those values. Once again, you have to make sure that you put the x values in the order that they would appear on a number line. So negative 5 is going to be before that 0 when we think about it in terms of a number line. So let's choose some x values that live in each one of these regions and see what we can say in terms of our values for y. So left to negative 5, we can choose an x value like negative 6. And what I'm going to do then is think about what happens when I plug a negative 6 in to each one of these factors and ask what's happening with the sign. So we have a positive 3 times a negative 6 squared. Negative 6 squared is going to be a positive 36. So we have a positive times a positive, that's going to be a positive. And then we have a negative 6 plus 5. Negative 6 plus 5 is a negative. So if I multiply that positive times that negative, that means then that we are going to have a negative answer in that particular region. Now between negative 5 and 0, we could choose something like an x value of negative 3. Well, negative 3 squared, once again, is going to be positive, so that first factor is going to be positive. And then negative 3 plus 5 is going to be a positive as well. Positive times a positive is going to be a positive. And then finally, to the right of 0. So let's choose something like an x value of 1. 3 times 1 squared, well, that's going to be positive. And then we have 1 plus 5, that's going to be positive as well. Positive times a positive is going to be a positive. So this time then, as we look at our inequality, we have greater than 0. Well, greater than 0 is going to be equivalent to saying positive values. So I want to come in and find all the regions where our y values are positive. So over here to the left of negative 5, our y values were negative. Not interested in that region then. Between negative 5 and 0, we have positives, so I'll color in that. And then to the right of 0, we also have positives. I'll color that in as well. Once again then, now we have to think about what's happening in terms of those values at the ends of these regions. So negative 5, well, if I plug negative 5 in here, I'm going to get a 0. 0 is greater than or equal to 0. It satisfies the inequality. So I do want to include that negative 5. Well, thinking about the author's use of parentheses and square brackets, we could go ahead then and use a square bracket to demonstrate that idea that we're going to include that negative 5. We also need to do the same thing at 0, because it's possible on some of these problems that you're going to get close to 0 but not include the 0 itself. So let's see what happens when we plug in that 0. If If I plug in 0, this again is going to be 0 on the left-hand side. 0 is equal to 0. So yes, 0 is going to be included as well. So I can go ahead and just fill that in and color it in. So as I look at this picture then, I have everything to the right of -5 colored in. And I'm including that -5. So my answer then is going to be square bracket -5, comma, infinity.